Hello. So for your lab report, you needed to calculate Q, which is the heat, and if you had this data here, so for part B, trial 1, this is sodium hydroxide plus HCl. We have 1 molar NaOH, and you use 49.9 mils, and then 1.1 molar times of HCl, and then 50.1 mils. These are your temperatures. And then this is the highest temperature here is the 28.4. So that was for trial 1. And then you might have data for trial 2. I'm just going to do the calculation for Q just for trial 1. Okay, so Q equals M times delta C. I'm sorry, C, which is specific heat. So M equals mass. This is specific heat. And that is a known value. And then delta T equals change in temperature. All right, so to get M, I'm just going to start with the mass here. And this is the total mass of your solution. And to get this, you're going to assume that the density is 1. Okay, so for the mass of NaOH, that for my data is 49.9 mils. So I'll have 49.9 mils equals 49.9 grams of NaOH. For the mass of HCl, that was 50.1 mils equals 50.1 grams of HCl. So the mass total equals, it's probably 100. .0 grams total. Okay, so that's the mass. C is the specific heat, which is the known value. That's 4.184 joules per gram times degrees Celsius. And that's for water. You can also write it as 4.184 joules over gram degrees Celsius. Alright, for delta T, I'm going to change the color of the ink here because you can't really tell the difference from that. So this is change in temp. Delta T equals the temperature final minus temperature initial. And you can use the temperature of NaOH if you want. The two values are pretty close together, so you can take the average or just do it for sodium hydroxide since that was what was in the calorimeter. So my delta T will be 28.4 degrees. So that was the highest temp, 28.4, and then it'll be minus 21.3. So that will be 7.1 degrees Celsius. Okay, so to get Q, we just have to plug all of these into the equation. So again, we have Q equals M times C times delta T. So our mass is 100.0 grams. And then that's times 4.184 joules per gram degrees Celsius. Times 7.1 degrees Celsius. Okay, so what you will see is our units for grams will cancel out and Celsius cancels out, so Q should be in joules. So I got 2970.64 joules. My values here, I have two significant figures. So you can do 3.0 times 10 to the third joules. So that would be Q for that. All right, and then you can do the same for trial 2, and then the reaction would, or the Q calculations would be the same for KOH and also for HNO3. Okay, and to calculate delta H reaction, you have delta H reaction equals Q over the number of moles. Okay, so your reaction that you did was HCl plus NaOH gives H2O plus NaCl. So to get the moles of water that was made, you have the volume of, in liters, of the base times the molarity in moles per liter of base. So that will equal 0.050 liters. I guess it would be 0.0499 liters times 1.0 molar or moles per liter of NaOH. Alright, so 0.499 times 1 mole of NaOH. Again, that comes from here. You had 1 molar NaOH and you use 49.9 mils. So liters will cancel out, and then we get 0.0499 moles. Okay, so I'm going to continue this here. So we have 0.499 moles of NaOH, so that's how many moles of water we can make. Because of the 1-to-1 ratio here. So to get our delta H reaction, that equals Q over moles, and our Q was 3.0 times 10 to the third joules over 0.0499 moles. .120 joules per mole, and we have two significant figures, so this will be 6. We also want to report in kilojoules per mole. .60 kilojoules per mole. Or you can do 6.0 times 10 to the fourth. Oops. Kilojoules per mole. So that would be how you calculate the delta H reaction. Okay, so for part D, It's a similar process. This is with the salt. We have to calculate Q again. For M, you use the mass of the salt plus mass of water. And this, your data might look something like this. So the mass of the water was 20 grams, because that's how much water I used, 20.0 mils. And the mass of the salt is 5.013. And then C is the same. And then delta T. Again, my temperature final was 9.8, and then the initial was 19.1. So I'm just going to switch these around here. All right, so we just plug those back in. We have two significant figures, so this becomes 9.7 times 10 to the second joules. Okay, and to get delta H reaction, that is Q over moles, and that will be the mole of the salt. So moles of KNO3 equals your mass of KNO3 times the molecular mass, so 101 grams of KNO3, and this is 1 mole of KNO3. So 5.013 grams that I used. So this equals 0.0496. Here we have 4 significant figures. I'm going to go on 3 moles of KNO3. So my delta H reaction equals 9.7 times 10 to the second joules. for 0.04963. And it'll round to 20 kilojoules per mole. So that is how you do the reactions for the salt. If the reaction is endothermic, your value should be positive. If it's exothermic, it should be negative. So this one was endothermic, it got colder, so it should be positive.